Good day. Our lesson today is on Unit 9, Lesson 7, Change of Base. Our benchmarks, MA 912, NSO 1.6. Given a numerical logarithmic expression, evaluate and generate equivalent numerical expressions using the properties of logarithms or exponents. MA 912, NSO 1.7. Given an algebraic logarithmic expression, generate an equivalent algebraic expression using the properties of logarithms or exponents. And MA 912 AR 5.2, we're going to solve one variable equations involving logarithms or exponential expressions, and then interpret solutions as viable in terms of the context and identify any extraneous solutions. Our learning targets. I can generate equivalent expressions using the properties of logarithms and the properties of exponents. I can use the properties of logarithms or exponents to solve one variable equations. And I can generate equivalent logarithmic and exponential expressions using change of base. So let's collaborate. The equality property for exponential equations. So you can work with a partner or do it yourself to write how the equation 7 raised to the d power is equal to 7 to the 4th power. How should that be read out loud? I just did it for you. 7 raised to the d equals 7 raised to the 4th. What value of d makes this statement true? So looking at your bases, that the 7, that's your base. Now looking at the exponent, d is equal to what? That's right, 4. d is equal to 4. Now for number 3, it says to rewrite 3 squared raised to the 3rd power using the product of powers law. These are lessons that we've covered before, prior to now, using those exponent laws. So rewriting that, 3 to the 2nd, that's right, that's 9. So 9 to the 3rd power. Number 4, rewriting 3 to the 2nd raised to the 3rd by first finding the value of 3 squared, which we just did. 3 squared is equal to, that's right, 9. Now discuss with your partner, or you can talk about it. If 3 to the 2nd raised to the 3rd is equal to 9 to the 3rd is true, verify your answer with a calculator. So here are the answers written out. And for number 5, you can see, yes, 3 to the 2nd is equal to 9. So 3 to the 2nd raised to the 3rd is equal to 9 to the 3rd, which is also equal to 729. Now here, we're going to rewrite the expression 9 to the 5th using the base of 3. So we know 9 using the base of 3, 3 to the 2nd gives us 9. So there we go. It's 3 to the 2nd. All of that would be raised to the 5th power. That's correct. Now work with your partner or by yourself to complete the steps that would solve 9 raised to the 5x power equals 3 to the 15 power. And then you're solving for x. So first things first, you need to make sure you have the same base on each side of that equal sign. So we have 9 as our base on the left side and 3 as our base on the right side. So we need to make sure that we have the same base. And we're going to use the base 3 on both sides. So we know 9 using the base 3, it would be 3 to the 2nd power. So here we go. 3 to the second will be raised to the 5x power equals 3 to the 15th power. So multiplying out just your exponents, that will give us 3 raised to the 10x power equals 3 to the 15th power. And all you're doing is taking your exponents, the exponents that have the variables in it, so we can solve for x. So that will give us 10x equals to 15, and simplifying, divide both sides by 10. X is equal to 15 over 10, but when it's simplified, it will be 3 over 2. Okay, let's rewrite each expression in the table so that they have the common base indicated. So we have 27 to the 4th power and 81 to the 3rd power. And they want us to use a common base 3 to rewrite that expression. So look at the examples listed. I'll give you a minute to go ahead and try to figure this out on your own. Okay, let's look to see if you were correct. 3 to the 3rd does give us 27, sorry. That's going to be raised to the 4th power. And 3 to the 4th power gives us 81. That will be raised to the 3rd power. For the second one, 4 raised to the 3rd power, we know base 2. Using base 2, 2 to the 2nd power gives us 4. And that's going to be raised to the 3rd power. And 8, 2 to the 3rd power gives us 8, and that's going to be raised to the 2nd power. We're just rewriting these expressions. 16, using the base 4. So 4 squared gives us 16. That's going to be raised to the 6th power. And 64, that would be 4 to the 3rd power, raised to the 4th power. And then 16 to the 10th, we're using the common base 2. 2 to the 4th gives us 16, and that's raised to the 10th power. And 32 raised to the 8th power will give us 2 to the 5th power, all raised to the 8th power. Very good, those of you who figured it out. All right, so here, let's explore finding the values of x in each exponential equation. So on the left, they give you the equation. Let's start with the first one. Make sure your bases are the same, and in this case, it is. So over on the work and solution part, the right side of this table, what you should have in that table would be 2x plus 4 equals to negative 2. And then work it out and solve it. For the next one, we have 8 raised to the 7x minus 1 equals 64 raised to 9 plus 2x. So right now, we don't have the same base. So let's use the base 8. On the left side, we don't need to change anything. But on the right side, 64, using base 8, we know 8 to the 2nd power gives us 64. So that will give us 8 in parentheses, and your exponent should read 2 parentheses 9 plus 2x close parentheses. And then you solve it. 7x minus 1 equals 2 parentheses 9 plus 2x close parentheses. and work it out, solve for x. On the next screen, you will see our solutions. Let's look at the third example. We have 4 raised to the x power equals 2 raised to the 7x plus 12. We don't have the same base, so we need to use the same base on both sides of this equation. So let's use base 2. Always use a smaller base. Okay, so if we're using the base 2, we know 2 to the second power gives us 4. So on the left side, that should have 2 in parentheses, and your exponent should be 2 times x. The right side will stay the same. So here's what they should look like. And it's worked out for you. I'll give you a minute. Just remember, you can pause the video at any time to make sure you have everything written down in your notebooks. Okay, 5 more seconds. All right, let's move on. So for this one, let's complete this statement. If the blank are the same on both sides of an equation, the exponents are blank. Thus, you can set the powers blank to each other to solve for a variable of interest. I'll give you 5 seconds. Okay, make that 30 seconds to figure out what those missing pieces are. All right, let's see what you've come up with. So if the bases are the same on both sides of an equation, the exponents are equal. Thus, you can set the powers equal to each other to solve for a variable of interest. Very good if you figured out what each of those terms were, what was missing. Now let's try this. I will give you a minute. To do letters A and B. Remember, you need to have the same base on both sides of the equation. All right, let's see how well you've done. There we have it, base 5 for letter A. 5 to the third power gives us 125. and that's raised to the 2x minus 2. On the right side, 5 to the second power gives us 25, and that's raised to the 3 minus x. So now we have the same base. We're just using the exponent portion to solve for the letter, solve for x. And for b, for letter b, 1/6, if we remember our negative exponents, negative exponents. Remember when we flip those fractions or flip the whole number, it becomes a fraction. So it will be 6 raised to the negative 1 power raised to the x minus 3 equals 6 to the raised to the x minus 1. And just your exponents you're going to use to solve for x. Very good. Those of you who came up with this on your own, you're doing great. All right, let's move on looking at equality property for logarithmic equations. So it says if b raised to the x is equal to b raised to the y, then x is equal to y for real numbers where b is greater than 0 and b cannot equal to 1. So let's determine if the equality property for exponential equations also applies to logarithms. Show your work that leads to the property or explain your thinking. And then we're going to apply your thinking to solve each of these equations. Just remember, you need to have the same base. And in this case, on the left side, we have the same base, log 4. So all you're taking, what's in the parentheses? 5q plus 3 is going to equal to 6q plus 7, and then solve for q. On the right side, we still have the same base, the natural log. You're taking 17w plus 10 is equal to 37w plus 2. Solve for w. And I think at this point, we all should know how to do solving equations. If not, here's what it should look like. So to answer the first question, yes, the equality property for exponential equations does also apply to logarithms. The variables will be in the part of the logarithm and can be set equal to each other if the bases are the same. So for number 2, applying that thinking, we solved for each of those letters. Q is equal to -4 and W is equal to 2 over 5. So calculators only have the common logarithm shown. So a common logarithm has base 10 or e. So log base 10 x is equal to log x. And log base e, x is equal to ln x. That's the natural log. So this is information that you will need, change of base. Okay, so let's use the table to investigate how to find the value of a logarithm with any base using a calculator. So remember, going back using those properties, here the first one is done for you, most of it. So we have logarithm base 3, 729. So the exponential form, see, they took the base and raised it to the x power, equals to the 729. So just like what we did before, change your base. Make sure we have the same base on both sides. 3 to what power will give us 729? So here they tell us x is equal to 6. So to find that, the value of log a, which is log 729, over log 3, that's going to equal to, that's correct, 6. And it would be the same for the ln, the natural log. ln a, which is ln 729, over ln b, which in this case is ln 3, that's also going to equal to 6. Okay, try the next 3 problems using the same method. All right, let's see how well you've done. So if you look at the base, you can see what they give you. They give you the base already. For the second one, log base 5, so we know it should be using the common base 5. 5 to what power will equal to 625? And to figure it using the calculator, you'll type in 625, hit the log, then hit division, and then type 5 and hit the log and equal sign. It should give you your value of 4. Same with the ln, the natural log. Look at the next one, log 4. 4096. 4 to what power will give us 4096? So log, you're taking 4096 and hit log, division, 4 log, equal sign will give us 6. And the last one, log 8, log of base 8 is 32,768. 8 to what power gives us the 32,768? And that, in this case, it will be equal to 5, using the same method. Okay, so the change of base formula. When you look at it, log base B A is equal to log base C A over log base C B, or log B base B A is equal to ln A over ln B for any positive number A, B, and C, with B not equal to 1 and C not equal to 1. So the change of base formula is used to evaluate any logarithm with a base other than 10, or e when using a calculator. So let's try to rewrite y is equal to log base 7x using the change of base formula. I'll give you a few seconds. What would that look like? There we go. You are right. Y is equal to log x over log 7. Rewriting it using the change of base formula. So let's have you work on some of these. Use your calculator to evaluate. Give you a minute. You can always go back to previous slides to see how this is set up and how it's done. Ten seconds. All right, let's see what you've come up with. So the first one, log 987 over log 13 should equal to 2.688. And you're rounding to the nearest thousands, or where necessary. Log base 6, 3.14. It's log 3.14 over log 6, which equals to 0.639. And this, you're rounding these as best as you can. Log 216, log base 216, 6 is equal to log 6 over log 216. And that should give you 0.3 repeating, or 1/3. And then log base 49, 2401 is equal to log 2401 over log 49. That would equal to 2. Thank you so much for your time, and this lesson was on change of base using our logarithms. Have a good day.